Ever played hide and seek with something that makes up 80% of the universe? That's what scientists have been doing for decades. Dark matter is everywhere, affecting everything, but we can't see it. Let's crack this cosmic mystery together. Back in the 1930s, astronomer Fritz Zwicky noticed something weird. He was watching galaxies in the Coma cluster, and they were moving way too fast. According to the math, these galaxies should have been flying apart like a cosmic game of marbles, but they stuck together, held by some invisible force. Zwicky called this mysterious stuff dark matter, because, well, it was matter that was dark. He basically told the scientific world, hey, I think there's an invisible bouncer keeping these galaxy parties from getting out of hand. At first, everyone thought he was a bit nuts, but then more evidence started piling up, and scientists had to admit there was something supermassive hiding in plain sight. Fast forward to the 1970s, when Vera walked onto the cosmic dance floor and noticed something bizarre. She was studying the Andromeda galaxy, watching how stars moved around its center. Here's the thing, stars on the outer edge should have been moving slower than the ones near the middle, like ice skaters spinning with their arms out. But nope, these stellar partygoers were all moving at the same crazy speed. It was like someone had cranked up the galaxy's rotation to maximum and broken the physics DJ booth. Rubin's observations were rock-solid proof that some invisible force was keeping these stars from flying off into space. Her work turned Zwicky's wild theory into a scientific slam dunk. Here's where things get mind-bending, literally. Dark matter doesn't just pull on stars and galaxies, it messes with light itself. When light from distant galaxies travels through space, it should move in straight lines, right? Wrong. Scientists spotted light taking bizarre curved paths, bending around seemingly empty space. It's like watching a laser pointer's beam curve around an invisible beach ball. This cosmic magic trick is called gravitational lensing, and it's one of our best tools for mapping dark matter. Think of it as nature's funhouse mirror, except instead of making you look taller or shorter, it reveals massive clumps of invisible matter scattered throughout space. Pretty neat for something we can't see. Imagine two galaxy clusters having the biggest cosmic fender bender in history. That's the Bullet cluster, and it's the closest we've come to catching dark matter red-handed. When these clusters smashed together, something wild happened. The regular matter, all the stars and hot gas, got tangled up and slowed down like a galactic traffic jam. But the dark matter, it just ghosted right through, completely ignoring the crash. We know this because gravity was bending light around empty space where there shouldn't have been anything. It's like watching two clouds of confetti collide, but the shadows keep moving as if nothing happened. This cosmic pile-up became our smoking gun, solid proof that dark matter plays by its own rules. So how do you catch something invisible that barely interacts with anything? You build the world's most sensitive traps and hide them deep underground. Scientists have created these amazing detectors filled with super pure materials like liquid xenon. Fancy, right? They're buried in old mines and under mountains to block out cosmic rays and other annoying particles that might mess up the readings. Think of it like trying to hear a whisper at a rock concert. You need to get rid of all the noise first. These detectors are basically waiting for a dark matter particle to accidentally bump into them, like a cosmic game of tag. And when I say sensitive, I mean sensitive. These machines can detect movements smaller than the width of an atom. Sure, we haven't caught dark matter yet, but every failed attempt tells us something new about what this cosmic ninja isn't. Let me blow your mind real quick. Everything you see in space, all the galaxies and stars, they're actually following a hidden blueprint. Dark matter forms this massive cosmic web, like the steel beams of an invisible skyscraper. Imagine pouring water onto a spider's web. The droplets collect where the strands cross. That's exactly how normal matter behaves, flowing along dark matter's invisible highways and clustering at the intersections. This dark matter framework started forming right after the Big Bang, creating gravitational valleys where normal matter could pool and eventually build the galaxies we see today. Without this invisible scaffold, our universe would just be a boring soup of evenly spread atoms. Here's a fun fact. Scientists have gone through more failed dark matter candidates than I've gone through failed New Year's resolutions. First up was MACOs, massive compact halo objects, basically invisible planets and dead stars. Cool name, but nope. Then we had brown dwarfs, those stars that never quite made it to stardom. Another swing and miss. Some folks thought maybe we just didn't understand gravity. That's Mond theory for you. But after the bullet cluster crash, that idea took a serious hit. We even considered tiny black holes left over from the Big Bang, but they're just not common enough to explain all the missing mass. It's like playing the world's biggest game of Guess Who, and the answer keeps being none of the above. Here's a wild thought that keeps physicists up at night. What if our entire understanding of gravity needs a complete rewrite? Some scientists think we're like medieval doctors trying to understand a fever without knowing about bacteria. Mond theory suggests that gravity acts differently on huge scales, kind of like how water behaves differently in a bathtub versus an ocean. TVES theory takes this even further, adding extra dimensions to gravity. And there's modified gravity, which basically says Newton and Einstein's theories need serious upgrades. These ideas are super creative, but they keep hitting the same roadblock. They can't explain everything dark matter does. Still, they're forcing us to question our most basic assumptions about how the universe works. Right now, millions of dark matter particles are zooming through your body every second. Weird, right? Scientists estimate that in your room alone, there's about a coffee cup's worth of dark matter. But don't worry, these particles are super shy. They're passing through everything like cosmic ghosts, barely bumping into regular matter. In fact, a dark matter particle could travel through a wall of lead a light year thick and probably never hit anything. Think about that next time you're lying in bed. You're actually swimming in an invisible cosmic soup that makes up most of the matter in our galaxy. The dark matter in our solar neighborhood moves at about 220 kilometers per second, forming a huge halo around the Milky Way. The dark matter hunt is about to get a serious upgrade. Scientists are building detectors the size of office buildings, filled with tons of ultra-pure xenon kept at temperatures colder than space. The Darwin project in Europe is like a dark matter fishing net that could catch the tiniest particle ripples. Meanwhile, China's PandaX experiment is going supersized, and the LX Zeppelin detector in South Dakota is pushing the boundaries of what we can measure. Think of these machines as cosmic security cameras, but instead of catching burglars, they're waiting for the universe's most elusive particles to slip up. If dark matter is out there, these next-gen detectors will be our best shot at catching it red-handed. Thanks for joining me on this cosmic hunt for the universe's most mysterious missing mass. If you enjoyed unraveling this space mystery, smash that like button and subscribe for more mind-bending science. Share with your friends. Let's solve this puzzle together.